Hello, hello. This is Postgres FM episode number 58. And my name is Nikolai, and together with me, Michael. Hi, Michael.
Hello, Nikolai.
And we are going to talk about sharding today. Sharding. Two big experts of sharding are here, are going to discuss sharding.
Yeah, definitely not an expert here, but this came up last week as a topic. Somebody suggested partitioning and sharding as a topic for a monthly
Friday.
Yes, the monthly blogging event that I'll link it up in the show notes. But yeah, we've done an episode on partitioning. I thought it was a really good one. I really enjoyed that and learnt stuff, and I think we got some good feedback on it. This though is sharding, and I think maybe that is a good place to start. Like what the difference is. I tried defining it. You gave me some feedback. How do you define them?
Well, partitioning is when we split tables, but we remain on a single node. I mean, we might have read-only standby nodes, but if we count only primary nodes which have read-write access, it's only a single node. But once we do similar split involving multiple primary nodes, we should call it sharding instead of partitioning. And the name, I guess, came from some game in the past.
Oh, really?
Yeah, it's some game, online game, and they called shards some. I should not lie. I was not prepared to explain etymology here, but part of my brain says it's from some game, from gaming, and they called shards some parts of the world, of gaming world. It's basically if we move this concept to databases, we have database sharding.
I really like your definition. It's the one I tried to go with in my blog post. So partitioning is at the table level, splitting what's logically one table into multiple tables, and sharding is the same but at the database level. So it's splitting what can logically be thought of as one database, but is actually behind the scenes multiple databases.
Right.
So that makes sense to me, except and I think it's worth warning listeners, lots of blog posts you read out there, definitions, even on Wikipedia and other places that are normally quite accurate, they do often use the word partitioning in places that I think would more accurately be described as sharding. So it is confusing out there.
The CAP theorem, its official terminology, network partitioning, right? So, and network partitioning, it's in negative connotation, it's like in our case, we should call it network sharding, but it's doesn't make sense. Also, there's some confusion around vertical versus horizontal. And, I don't understand why confusion, but I see people try to say vertical sharding, which actually just vertical split of, maybe functional split of databases to multiple databases. For example, you see weak connection between two groups of tables. We could say clustering here as well. And actually, we can apply some machine learning approaches like basic k-means to try to automatically detect good options for vertical split of databases into sets of tables with weak connections. Weak means almost no foreign keys between them, and also dynamic relation. When we have two tables involved in a query, it's also a connection. Though it's not static as foreign key, it's dynamic. So I used it. I used machine learning to try to help people understand how to split databases vertically. Vertically means, users are here, products are there, right? And connection between exists, but we don't do it often. Well, maybe it's not a good example, but I think it's clear when we have different data in different parts, different primary nodes. But horizontal means we basically take our table and split it using horizontal line, right?
So I see it as I think the partitioning case is actually simpler to explain. So horizontal partitioning is at the row level. So we're taking some rows from the table and putting them on a different node. In a different table. And vertical would be column based. So we're splitting the table based on the columns into two different tables. Now it's the same, but for sharding, right? Like we don't have the same column. It's kind of still columns and rows, right? But we're just taking columns as a whole table and putting them somewhere else. And in the horizontal case, we're taking row level data. So we have the same tables across different nodes, but different rows in each one.
Vertical column level, okay, it means like if you studied database theory, it should be called like projection, when you have only limited set of columns and the other columns go to different table. You probably have a one-to-one connection between them, relationship, sorry. And I agree. And if you do it at server level, it's just functional split. We should call it functional split. And this is a normal approach to scale your system. If you prefer microservices or just mid-size or big-size services approach, when you split some functionalities in one database and other functionalities in another database, so they have some connection. Of course, maybe they have some common part, and you need to take care of replication. But majority of data is very different in nature. Versus, row level means like we have same sets of tables, but different data, because some part of data goes to one node, some different part of data goes to another node. So how do we do that? Let's talk.
Well, do you want to do how? Or I was thinking maybe we could start with why. Like why even do this?
Why is simple? Well,
I think there are a few reasons, to be honest. I think they're different.
There's only one big
quite
reason,
different.
and we know it. Performance.
Well, scale, right? Like when you say performance, it's
they are related.
We're talking about. I like it. I think it's the main reason you would ever want to shard, which is hitting a max. Like, let's say you're super keen to stay on Amazon RDS Postgres, and there's a max size that you can provision, and on some basis you're getting close to maxing that out. Maybe your CPU's going up, maybe your ingest rate. Like, there's some level at which you're scared, well, we can't continue to grow this vertically. We can't scale up anymore. Is that what you're talking
you
about?
just used the word vertically in different sense. I mean, vertical scaling when we just add the resources, more CPU, more memory, better disks.
So yeah, that's what I meant. What I meant is, if we get to a point where we can't do that anymore, we need to think about sharding.
No, not necessarily. Like again, like you just used again. I will repeat. You used the word vertical scaling, where vertical word is in different sense compared to what we just discussed. When we talked about columns, you used the word vertical in the sense of hardware resources. So, I mean, if we cannot add more CPU and RAM, vertical scaling, we probably still can split our system vertically in terms of tables and columns, and have different parts of our schema in different primary nodes.
Yeah, I agree, but I thought we were counting that as a type of sharding.
I don't like to call it sharding at all, but I see people do it. Vertical sharding. Okay. Yeah. For me, it's like just functional split, or like go in microservices architecture or something. And it has some of problems which this approach has are similar to normal sharding. For me, normal sharding is horizontal sharding.
Yeah, okay.
When we don't specify vertical or horizontal, usually we mean horizontal sharding. Same scheme everywhere, but different data, right?
I completely agree. Same with partitioning. If you don't hear somebody say horizontal or vertical, they mean horizontal.
Right. And vertical partitioning also, like, it's not common. Some people use it again.
Yeah.
It's just it's an attempt to have some unified terminology for everything, and have some, some table 2 versus 2 like table. But okay, so we cannot live with one primary node. We are saturated. We tried everything offloading read-only queries to standby nodes. Reduced frequency probably with some caching, with some optimization, and so on. We still see that we are growing, and soon one node is not enough. It's a very painful situation, very scary, especially for CTO and so on, to suddenly to hit the ceiling. And of course, in this case, usually people choose one of two directions as the main one, like again vertical split or sharding right away. But sometimes they need to mix. If it's a really large project, you start with, like, you bet on one approach, but still need to apply the different one as well.
Yeah.
Right? So if you like microservices, and microservices is a bigger than technological topic. It's not just technological. Microservices is organizational topic. You need to change management and how teams are organized.
Yeah.
How they choose technology. They probably choose not Postgres. Some teams might choose not Postgres but something else, and so on. So it's a bigger than just technical discussion. But if you choose microservices, probably you don't need sharding, right? Microservices approach either solves this problem of saturation and inability to scale, or it just postpones it so much that you have like 5 years or so, right?
Maybe, like, the thing I don't understand about microservices is, like, what if you've got one thing that's very difficult to split logically, and that is the most heavy ingest rate of everything? So you could easily have quite a small team looking after one huge node in the microservice infrastructure. So I suspect you could still hit this with, if you've got like a load of IoT sensors or something, you could get a lot of data very quickly. So yeah, I think it's possible even in the microservices.
I cannot agree here. A lot of like if you, for example, an e-commerce and a huge one like continental leader, for example, and I have a few examples Postgres based which I worked with directly or I just learned from them based on discussions with the people involved. So if you choose microservices and e-commerce, most of e-commerce systems somehow tend to choose microservices approach. They love it. I mean, engineers, backend engineers and managers, they usually choose microservices. In this case, it's very hard to imagine that one of services, which usually you have, something related to registration, inventory, orders, and so on, many services in typical e-commerce. It's hard to imagine that one of them will require sharding right away. You need to grow a lot to start to see the need in sharding of one of those services.
I agree for e-commerce. Yeah. So, but I wanted to run one other. I think there are some sharding or things that get called sharding that are horizontal but have a different primary driver, I think, and I think that's analytics query performance.
Okay. I silently reduced the topic to OLTP as usual for me.
Yeah, okay.
But I agree. OLAP, analytical systems, they can have a lot of data, and usually sharding there is definitely a good thing to have. So I agree with you here, definitely.
Cool. So a couple of reasons at least for wanting this, but yeah, I think how is probably a good thing to move on to. Like, what are our options?
Right, how? So unlike MySQL world where Vitess exists, we don't have Vitess in Postgres, and attempts to migrate Vitess to Postgres failed. I know a few, and the developers of Vitess announced that they don't pursue this goal anymore. But we have a few options. Citus, first of all, and again, like I had a joke about we are big experts because I consider myself not an expert in sharding at all, because I reviewed Citus and played with it a couple of times in the past, but it was before Microsoft has decided to open source everything.
Yeah.
So I always considered only open source part because I didn't want to have vendor lock-in to Azure. But right now we have interesting situation. They open sourced everything, so it's worth reviewing once again, especially the very important feature for large and growing projects, rebalancing without downtime.
Yeah.
It's super important for sharding because you never know which node will grow. It's hard to predict, so you need some tools to change distribution of data in the future, but without huge downtime. And this feature was originally only in paid version of Cytus, but now it's open source as well. But I lack up-to-date knowledge. For me, if we talk about OLTP, I usually asked, I talked to them, to Cytus team, couple of times and asked, please provide cases of pure OLTP, good, like heavily loaded systems with OLTP workloads. But everything they provided that time, it was like 2, 3, 4 years ago, it was looking as HTTP to me, not OLTP. You understand what I mean?
So hybrid transactional analytical.
For example, some search and analytical engine for videos or something where it's okay, like only limited number of users and they are motivated to wait a couple of seconds. In this case, it's okay, to have some latencies. But in OLTP, we have only usually dozens of milliseconds or just hundreds of milliseconds, but not a second. A second kills our traffic and people go away. So we cannot wait. We cannot allow waiting so long. And when I benchmarked myself, Cytus was not behaving very well for OLTP. But then I've got some response on Twitter from developers that I do some things wrong. So very likely I did some things wrong. I was trying to measure latency overhead. This is my favorite test for such systems, because the biggest problem for performance when splitting is not that difficult, but when you have something that decides which shard to go, router, right? It adds overhead because it needs to parse the query, and parsing query and so on requires time. So this adds overhead, and for me in OLTP case it's unacceptable to have overhead more than a millisecond. Millisecond is quite big already.
What were you seeing? Was it in the
I don't remember details.
Or, okay.
It was.
But yeah, you can imagine if it was. Imagine if it was, and I'm not saying it is. Imagine if it was tens of milliseconds. You would deem that completely unacceptable.
Yeah, definitely, because it's already very close to human perception threshold, which we know 200 milliseconds. And we need probably multiple queries to serve one HTTP request, so I cannot accept that overhead at all, because I know my backend engineers will add milliseconds on their own. They know how to add more milliseconds, so I cannot allow this proxy middleware, right? I cannot allow it to have significant overhead. But again, my benchmarks very likely were not ideal because of this feedback, and I never tried one more time. So probably it's time to benchmark again and see the overhead of Cytus proxy.
Yeah, I was going to say, and you're a few years out of date, right? If they open sourced it a little while ago, so you're at least that much out of date. And I think the latest version included schema level sharding, which seems quite interesting for some OLTP
specific
type split. Yeah, exactly. So
it's quite vertical, right?
If you were considering if someone's considering sharding and they're on Postgres, they're gonna look at Cytus. They should look at Cytus, but there are other options as well, right? That's the.
I would revisit this decision right now for OLTP, heavy loaded OLTP system. But again, benchmarks are needed once again, and probably some tuning and so on. And I still don't know very good examples of OLTP systems which use Cytus. But I'm not closely watching.
I looked at their looked at some of their customers, and some of them are very analytics heavy. So like Algolia for search, Heap I believe Microsoft used them internally for quite a few things. But Freshworks stood out to me as potentially, like, that's a help desk ticketing system, right? Sure, they need to search as well, but a large part of that is OLTP. So that seemed interesting to me.
Yeah, that's interesting. But an analytical area, let's look at Hydra, which recently released 1.0. Congrats to the Hydra team. Interesting, column-based. And they inherited this code from Cytos for Column Store. So it's interesting.
I looked at the Hydra website in preparation, expecting them to have something around sharding, but I think they've forked Cytos to do the other parts of what Cytos does well, like the analytical processing, but no mention of sharding anywhere on the Hydra website.
Maybe at some level you don't really need it if you have Column Store and vectorized processing. So I'm not an analytical guy. I'm not sharding guy. I honestly don't understand what we are talking here about.
Let's move on, because we do have some really interesting cases and write-ups and blog posts from recent OLTP company, like Notion and Figma both blogged relatively recently in the last couple of years about sharding Postgres.
In a way which I call application server sharding, ASS, which I also implemented myself a few times, and this is what you usually choose because you don't have proper tooling. And Cytos is proper tooling for OLTP. Again, maybe someone has good experience or knows about some good experience. I would like to know. Please comment anywhere, like on Twitter or on YouTube or anywhere. So we are watching everywhere. And yes, but applications server sharding or application level sharding, I like application server sharding because it's about this side. Application side sharding, sorry. This is challenging and requires an effort, definitely. And usually it's quite easy to split and so on, but you need to think about several things as usual. First is this rebalancing. In future, you will need it, definitely. Yep. And how to do it without downtime. Second is how to avoid distributed transactions. For example, it's an absolutely bad idea to have multiple connections to different primary nodes and work with them like in some messy way. You start transaction, you work with different connection, it also has transaction. If you do that, if you absolutely need it, you need two-phase commit, 2PC. But it's slow. So you cannot have thousands of TPS on 2PC at all. It's impossible. So it's very slow because it has its own huge overhead. So usually in OLTP context, we try to avoid 2PC unless absolutely needed. Mm-hmm. Right? And finally, you also need to take care of this router and should have small overhead. 1 millisecond is good. Probably that's it, high level.
Yeah, I think the Notion blog post in particular, there's two blog posts actually from Notion, one from 2021 where they initially did this and they shared a huge amount of detail in the preparation, how they chose things, how they were preparing for rebalancing, sorry. And then there's a follow-up blog post from this year from them talking about resharding without downtime, or with, I think, less than a second of noticeable impact on users, which is incredibly impressive. But they might have even used the word partition key or something. They chose to shard based on Notion account, or like what's it called, like workspace, because people aren't ever looking for information from two workspaces at the same time, so you don't have that same problem.
Yeah, that's actually the same as with partitioning. It's very difficult, and I saw cases when people spend a lot of time trying to find the ideal partitioning key, or sharding key in this case, or a set of keys. For example, unlike partitioning, where we can, for example, choose one key and it's enough, we also need to think about how write workload will be distributed among multiple nodes here. And for example, we know Timescale Cloud, they unfortunately not an open source, they have basically sharding as well. And there you need to have two keys. One is time-based, timestamp, but it's not enough. Why? Because if you just use only timestamp, you will have hotspot. One shard will be receiving most of the writes all the time. So you need additional some balance for balancing. You need a second level of second key basically as a part of complex key. So for example, a workspace ID could work here as well.
Timescale multinode is a really good point, actually. I was looking it up and it looks like you can self-host it. So even if it's not open source by definition.
It's interesting news to me. Okay.
According to I was reading some. I also thought that wasn't true until I checked the docs.
What is the license?
I didn't check. Sorry, but I just
they have two licenses: Apache and Timescale, which is open source.
I very much doubt it's not. I don't think they're doing anything on the Apache one anymore. I think that's their old stuff.
Okay,
but anyway, let's not guess. I'll link up the docs, and people that are interested can look into it themselves.
This episode is full of guessing, right? But let's return to this main topic. So you need to take care of these things, and you need to think about, as usually when you're architecting something, you need to think about how much of data you will have in 5 years, and how will you approach rebalancing with minimal cutover time. So you need probably involve logical decoding, logical replication. It's improving in latest Postgres versions, but it was a surprise for me in one case when it was not about sharding. It was about vertical split of a quite big system, and I was considering logical replication right away to perform a split, but split was like in 2 parts. Consider like in 2 parts. It's easy, like 50-50. And in this case, it's easier to use just physical replication than drop tables on both sides, which are not needed, because it's like easier to install. It's like it has less bottlenecks, fewer bottlenecks, and so on. So in some cases, just physical replication, and then you drop columns, tables you don't need. And also balancer and lag detection is interesting there. So let me add one more item, which is quite like huge item. If you go, doesn't matter microservices or sharding, you're going to have many more nodes, and in this case, operational side you should be better. Auto failover, backups, provisioning, balancing, everything should work much better, more reliably, and in this case it means that you need to simplify. If you rely on managed Postgres, probably it's also okay, but you need to trust it 100% and so on. But if you manage Postgres yourself, before increasing the number of primaries, you need to unify, for example, naming conventions. It takes a lot of time if you have different schemas of naming of hosts, for example, for different parts of your system. And then you design some very good tool which, for example, performs minor or major upgrade or something. And then you bump into issue of deviations. So you need to simplify, unify everything, because you are going to have many more nodes now.
Yeah, it's a great point. This is not cheap to add. Sharding adds a lot of complexity, so it's a good idea. That's a nice point to simplify things.
It's not about sharding, it's about just growing fleet in terms of clusters. You have more Postgres clusters, so you need unification and simplification and so on.
So I actually thought of thinking about the other options out there. I do remember hearing and reading up on EDB's product, it kind of in this area called Postgres Distributed. Now that kind of raises the point of a different use case for sharding, which is, one of the big advertised features of that is being able to keep data local to a region, for example. So like if you want to keep your
bidirectional replication involved.
So it's the new.
Let's detach this topic because it's very different and specific. It's not.
But by the definition, I agree with maybe we'll take it. Well, but by our definition of one logical database split into multiple physical databases, it kind of is.
But then you need to replicate in both directions and so on. This is based on the claim that logical replay is easier than initial apply of changes. And so far, I haven't tested myself. I saw it only in BDR documentation, but I don't think it's so. I think it's more marketing claim. I didn't see benchmarks. So let's keep aside bidirectional replication completely and return to this topic in a separate episode. And because we also don't have time for it right now, I also wanted to mention two different tools.
Okay.
First is pgcat. For example,
yes.
if you want to shard yourself, pgcat already offers simplified approach because it provides sharding in like originally provided sharding in explicit form. Application needs to say, okay, this needs to be executed, and I know on which shard in the comment. So like basically just some helper tool, but you need to take care of a lot of things yourself. But I saw this; they improved it, and some kind of automatic routing already there, and also overhead is quite low. I tested it long ago again, like a year ago maybe, and overhead was not bad at all for OLTP. It's written in Rust, so quite performant. Interesting. I would look at it, and it's been developed quite at good pace. And another is SPQR, from also under development. I watch changes in both repositories, and I see a lot of development happening in both projects. And this project was developed with more with idea of having more automated sharding tooling, similar to VTGate and Vitess.
Yeah, would you call that? Do we need another name for it? Is it almost like pooler level shard? If we've got application level sharding, is this pooler level?
Well, yes. Well, if in this case we can distinguish like application level sharding, application side sharding. It's when backend engineers is responsible for everything, basically, almost everything. Additional like software can be put like in transparent fashion. Yeah. Yes, we need to take care of rewriting some queries because we don't want to deal with multiple shards at the same time often. But we can distinguish at least two types of this middleware which helps us with sharding. First is like VTGate style or this SPQR style or pgcat, when something lightweight is placed and it doesn't include Postgres code, or at least majority of Postgres code. In this case, this tool needs to parse queries, Postgres queries. Postgres syntax is very, very advanced, so it's a challenging task. Grammar is huge. And another approach is placing a whole Postgres node in between. And in this case, I think latency overhead is quite significant. And this is what PL Proxy in Skype 15 years ago, developed more than 15 years ago, was doing. And it's quite interesting approach. I'm not sure about overhead, but it has limitations that you need to rewrite all your queries in the form of server functions, because it's a kind of language. PL Proxy, it's a language, which is similar to MapReduce approach. But overhead is interesting. But at the same time, Skype was OLTP definitely, and overhead requirements were quite strict. So, but it's similar to PGQ, a lost art or lost knowledge.
Well, if you like, I was thinking we could end on like, where do we think the future's going a little bit, and I think Vitess is a really interesting case. I do think we're kind of maybe at a point where the Postgres-based startups that started in the last 10 years or so are really at a scale that YouTube were at when they started needing this and they started building Vitess. And I wonder if maybe that is what we're starting to see with the likes of pgcat, that we're starting to see some of these companies that have been built on Postgres really needing some better tooling here for their own use cases, or as you said before, the bazaar of different options. Lots of people will build their own tooling, and maybe one of them will emerge, like Vitess did for MySQL, and we'll have that in 10 years' time. It'll be the same place, maybe.
I don't consider PGCat as a sharding solution. It's more like a pooler. But with very lean approach to development, when they decided why not having these, for example. And unlike PGPool, like they don't aim to solve every problem completely. For example, this explicit approach, when you as a backend engineer is putting a comment on which shard to execute, so you are responsible for routing, and there's it's manual routing, right? It works quite well. It's a simple feature. Why not, right? So I think with Postgres somehow sharding, very good sharding solution never existed, and Vitess has many features which usually are overlooked. For example, asynchronous flow of data between different parts of system, and if we consider a huge project, we shard different parts differently. So basically, we're already splitting to services, right? So we need to shard users in one way and products or orders in different way. In this case, we have basically two vertically split parts, and already then we split them horizontally. But in this case, we want to avoid dealing with multiple nodes. So why not having some kind of materialized views which would bring data asynchronously with some delay, but quite reliably, so we could work with local. So I mean, if you imagine some sharding system with ability to have different sharding keys for different parts of schema, plus you add materialized views with ability to be incrementally updated, not fully.
Yeah. Okay.
And ability to be incrementally updated asynchronously between nodes, plus also global dictionary, because sometimes you need some global dictionary, and also ability to synchronize everything. This is something like Vitess has already in MySQL world, but Postgres somehow don't have it, right? And I think it's possible to build it from bricks. It will take time, all these things, but somehow like full-fledged solution doesn't exist. Again, I'm lagging in terms of Cytos understanding, but because for me, there is a requirement on the overhead. If it's not passed, I'm already looking at different direction. And so right now, I would revisit Cytos, revisit PGCat and SPQR, and if test it for my case, and then go with application side sharding once again. Yeah. Unfortunately.
Last question from me. I think I saw. Go on.
For to have complete picture, there's also a third type of sharding maybe fourth type of sharding, when we don't shard in ourselves, when we don't have middleware, but we decide to split our system to multiple systems. If you talk about sharding, you talk usually about database split. But what if we split whole system? For example, we had only one website, but now we have 10 websites. But they have, for example, unified authentication subsystem. So you have one login, it works on each one of those 10 sites. And this can probably solve, you mentioned this problem, to have data closer to your customers. For example, you could have one website for one country, another website for different country. Maybe you have 100 of websites. They have single login system, and they have different databases. In this case, you split horizontally also, right? But you split not at database level, but at whole system level. So they have everything separately. What about this approach?
Yeah, and by the way, it's not just about speed. It's not just about latency of having data close to users. It's also about residency, privacy, legals.
Law.
Yeah, exactly.
Yeah.
But yeah, awesome.
But this approach is interesting for SaaS systems, maybe, like Notion.
Yeah, well, but interestingly, they didn't. They've there are a lot of benefits of keeping it as a single application, right?
Simplicity of management.
Or like having, let's say, I'm part of one company in the US and part of a different company in Europe. I can have my I can log into the workspaces within the same UI very easily. So I suspect
you can do it even if it's two different applications. You just need a single authentication system. It's possible.
Yeah.
Global one.
I think I saw a talk by.
So you use one login. It's for Google services. You use one login for many different services, right? It works. Similar here. We can have different systems. They are the same. If we forget about law details, right? Legal details. They are all the same, but you log in to all systems using a single login. It works everywhere, like seamlessly, right?
Yeah, I don't know if it would be quite as easy. Like,
it's not easy.
For example, okay. The last question I had was
it's not easy. Sorry, it's not easy, but you can grow a lot using this approach. Like scalability is infinite.
I think I saw a talk by GitLab talking about splitting systems out. I think there might be a recorded version of it, but I suspect you know more about it than me. Which route did they go?
Well, disclaimer: they are still my customers.
Yeah.
So I would recommend checking their documentation. It's very transparent. It's public. Most of things are public. They split vertically first. And it's obvious for systems like GitLab, because if you think they have a lot of functionality, but some kind of functionality is quite automatic, and it's related to CI/CD pipelines. And this is exactly what was moved to different database, CI/CD data.
Yeah.
It's quite like it's loosely it's coupled very well inside CI part, but it's not that connected to different parts. Oh, by the way, check out what they needed to do with foreign keys when performed this split, because they needed to create a new concept. I forgot the name, but basically how it works, it's like asynchronous foreign key check between two databases. So it's quite interesting concept, which helps you preserve at least something when you move data to different nodes, and this is useful. This experience is useful probably for other systems as well. And right now, I think they go to direction probably I don't need to discuss because it's still under development. But you can check their website documentation and open issues. A lot of information is open.
Yeah, foreign keys are notoriously difficult. I think that's something Vitess still is working on. Or might be soon even.
I forgot the name, unfortunately, but there is some name GitLab invented. They introduced some new concept for.
We can find it and link it up, right?
Yep.
Awesome. Thanks so much, Nikolai.
Good. Thank you.
Thanks everybody, and catch you next week.
Bye bye.